So let's talk about AWS API Gateway. If you're building on AWS, you already know how powerful it is for creating and managing your APIs, but what you might not know is that there's this whole set of hidden rules, these quotas and limits that can seriously make or break your application. Understanding them isn't just a nice to have, it's absolutely critical if you want to build something that's truly solid.
Think about it like this. You've just built this amazing superhighway for all your data to travel on. But what you don't realize is that AWS has put up all these invisible speed limits and roadblocks. And when you hit one of those at full speed, well, your whole app can just grind to a halt, throwing all sorts of confusing errors. So today, we're going to pull back the curtain and map out all those hidden rules so you can navigate them like a pro. So what are these quotas really? The most important thing to get your head around is this. They are guardrails, not roadblocks. Seriously, AWS isn't trying to slow you down for no reason. They put these limits in place to make sure the entire service stays stable and available for everybody. It's to stop one person's runaway process from ruining everyone else's day. And once you start seeing them as helpful guardrails, you can start designing your apps to stay safely on the road. Okay, let's start at the very top. The main speed limit for your entire account within a single AWS region. This is kind of like the main power line coming into a city. It's this big, shared resource, and every single API you build in that region has to draw from that same single source. And that mean speed limit is 10,000 requests per second. Now, here's the part that trips people up. This is not 10,000 RPS per API. It's for your entire account in that region. So if you've got a dozen different microservices, all with their own APIs, they're all sharing this one pool of 10,000 requests. It's a big number for sure, but if you've got high-traffic apps, you can hit that ceiling faster than you think. Now, to give you a little bit of breathing room, AWS also gives you a burst capacity, which is usually 5,000 requests. It works using something called a token bucket algorithm. Just imagine you have this bucket with 5,000 extra request tokens in it. If you get a sudden flood of traffic, you can use up those tokens instantly. It's a great little buffer for spikes, but once that bucket is empty, you're right back to that steady 10,000 RPS limit.
But, and this is a really critical gotcha, not all regions are the same. As you can see right here, a bunch of the newer regions have way lower default limits. We're talking 2,500 RPS with a 1,250 burst. So if you're deploying your application globally, you absolutely cannot just assume that 10,000 RPS limit is everywhere. You've got to check the local rules for each specific region you deploy in.
Okay, so that covers traffic. But what about the rules for actually building and managing the APIs themselves? Well, that brings us to a whole different set of limits. The best way to think about these is like the city's building permit office. There's a set speed at which they process the paperwork, and it doesn't matter who you are, you can't pay to make it go any faster. For instance, creating a new deployment. You can only do that once every 5 seconds. And you might ask, why? Well, there's a really smart reason for this. AWS is basically nudging you towards best practices. It's pushing you away from doing a bunch of frantic manual deployments and steering you toward building a proper automated CI/CD pipeline that deploys things in a controlled, predictable way. And it gets even slower if you're creating a new edge-optimized REST API. There, you're limited to just one request every 30 seconds. And that makes total sense when you stop and think about it. An edge-optimized API has to be set up across Amazon's entire global CloudFront network. That's a huge operation, and the quota just reflects how complex that is. Then for pretty much all other management stuff, like creating new resources or methods or API keys, all of that gets bundled under a general limit of 10 requests per second with a burst of 40. The big takeaway here? These limits are set in stone. You can't just file a support ticket to get them bumped. You have to build your automation and your deployment scripts to respect these rules from the start.
All right, so when you're kicking off a new project, one of the first big decisions you have to make is what kind of API you're going to build. API Gateway gives you 3 main flavors: the classic REST APIs, the newer, lighter HTTP APIs, and of course, WebSocket APIs for real-time stuff. Think of this choice like picking the right zoning law for a new building. Each one comes with its own specific set of rules that are really going to define what you can and can't do later on. And this table just lays out the trade-offs perfectly. Just look at the integration timeout. REST APIs are the only ones where you can ask AWS to increase it beyond that 29-second default. Or check out the payload size. If you need to send messages bigger than 128 kilobytes, a WebSocket API is just not an option. And then you've got WebSockets with a hard 2-hour limit on connection duration. These aren't just minor details. These are major architectural constraints you need to be thinking about on day one.
So we know the rules of the road. Now the big question is, how do we actually design our APIs so we can just cruise along without constantly hitting those limits? This part is all about being proactive, about building smarter, not just bigger, so you can stay within the lines without even trying. And here are some of the absolute best ways to do that. First up, the proxy path, sometimes called a greedy path. This is a game changer. Instead of defining hundreds of separate resources for things like /users/ID or /orders/ID, you can define one single resource that just catches everything and passes it to your backend Lambda. This alone can slash your resource count. Same idea with authorizers. Don't build a new one for every endpoint. Build one good one and reuse it. These little design choices make a massive difference.
Okay, we've gone over the big, headline limits, but you know how it is with any big service. The real danger is often buried in the fine print. So let's dive into some of the most important little notes and gotchas that can trip up even seasoned developers.
Here's a classic one. If you're using a custom domain for your API, you are not allowed to create resources at the root level called /ping or /bing. And you might be wondering why. It's because API Gateway reserves those exact paths for its own internal health checks. If you try to use them, your API just isn't going to work right, and you'll be pulling your hair out trying to figure out why.
This seems so small, right? But trust me, this quote from the docs highlights a super common reason that deployments fail. Your stage names like dev, staging, prod, they have to follow these very strict naming rules. If you try to use a period or some other special character in there, your whole deployment is just going to fail. It's a small detail, but you gotta know it.
This one is huge. Let's say you own the domain api.mycompany.com. You cannot point that single domain name to both a REST API and a WebSocket API at the same time. They're treated as totally different things by API Gateway. You have to use different domains, or maybe different subdomains, like api.mycompany.com for your REST endpoints and ws.mycompany.com for your WebSockets.
Now, for anyone working with WebSockets, this detail is absolutely critical. The total message size you can send is 128 kilobytes. Okay, simple enough. But the WebSocket protocol itself breaks messages down into things called frames, and a single frame can't be bigger than 32 kilobytes. So if you want to send, say, a 100 kilobyte message, your application code is responsible for chopping that up into 4 separate frames before you send it. API Gateway will not do that for you.
And finally, you have to be super careful when it comes to logging. API Gateway will literally chop off any log event, like a request or response body, after just 1,024 bytes before it sends it over to CloudWatch. So if you're trying to debug an issue with a really large payload, you're not going to see the whole thing in your logs. And on a similar note, if you have really long resource names, they can get cut off in your CloudWatch metrics, which can make your dashboards pretty confusing.
So let's bring it all back home to where we started. You can look at all these rules and see them as these frustrating roadblocks that are just causing you problems and blocking your work. Or you can see them for what they really are, guardrails. They're there to keep the service stable for everyone, to prevent noisy neighbors, and honestly, to nudge you toward building better, more scalable apps from the get-go. Once you understand the rules, your whole perspective changes.
In the end, knowing these hidden rules isn't just about avoiding a few errors, it's about being empowered. It's like having the official blueprint to build more efficient, more resilient, and even more cost-effective APIs right from day one. So the only real question left is, now that you have the map in your hand, how are you going to design your next API?